Hello, good morning everybody. How are you? So, today I will discuss the topic capacitor. And all of you know this is the part of electrostatics. So, basically some fundamental terms we have to know about this topic. First fundamental term is about the electric field, electric potential, and then I will discuss about the capacitor. So all of you know about the electric field and electric potential. Earlier I have already discussed in electrostatics. So today I will focus on capacitor only. So first I will know what is capacitor. Exactly, what is the use of capacitor? Where I will use the capacitor? So basically capacitor is the device or it is used to create the constant electric field inside it, or it store the charge and energy. Also it is used to filter the vibration in the circuit. Basically this is the main application of the capacitor. So basically capacitor is the arrangement of two similar plate. Similar plate means that what? If one plate is parallel, one plate is rectangular, then second should be rectangular in nature. If one is a square, then second should be in a square. One is spherical in nature, then second should be a spherical in nature. One is cylindrical in nature, then second one should be cylindrical in nature, like that. So in simple we can say capacitor is the arrangement of two similar plate. Arrangement of two similar plate. And their usage. Their usage to store the charge. To store the charge or energy to create electric field, create the electric field and maintain the vibration in the circuit. Vibration in the circuit. This is all about the capacitor. Now we will know why capacitor I will use in the circuit. So first three things I have already discussed. Now the major thing is how I will measure their strength. So the strength of capacitor is measured in term of capacity. In term of capacity, like the strength of engine is measured in term of efficiency and a lot of things related to this one. So capacity is basically defined as the charge stored in capacitor per unit potential. So charge per unit potential is basically capacity. Charge per unit potential, I mean C is equal to Q upon V. This is the charge, this is the potential, and this is capacity. Now the unit of capacity is farad. Their unit is farad or coulomb per volt. Coulomb per volt. Now I will analyze the capacity. So basically capacity is charge per unit potential. It means that their analysis is C is equal to Q upon V. So simply we can write delta Q upon delta V, we can write, and in a limiting form we can write limit delta V tends to 0. When I will take limiting form, in that case denominator should be tends to 0. So I am using here limit. So it will becomes delta Q upon delta V. It means that delta V tends to 0 means that what? Potential difference should be very small. I mean it should be near to 0. If it is near to 0, it means that it will becomes the differential form. Because all of you know, I have already discussed in the previous lecture, when change is very small, in that case we will use the concept of differentiation. So basically it is known as the differentiation of charge with respect to potential. So from here mathematical analysis we can do dq is equal to c into dv. So q is equal to integration of c into dv we can write. This is the mathematical analysis. So I have already discussed their unit should be coulomb per volt or farad, like that. And this is their mathematical analysis. Simply this term you have to keep in mind always. Capacity is equal to charge per unit potential, and this is their mathematical analysis. So how I will calculate the charge? So basically it's be with a differentiation of capacity with respect to potential. Now I will discuss about type of capacitor. How many type of capacitor we have to study? So it will depends upon the configuration of capacitor. First and second, it is also categorized on the basis of dielectric. So one by one I will discuss. First I want to discuss about the type of capacitor on the basis of, I mean category of differentiation on the capacitor on the basis of configuration of plate. So type of capacitor. First one is parallel plate capacitor. First one is parallel plate capacitor. Basically, this is the type of capacitor on the basis of configuration of plate. Configuration of plate. Configuration of plate means that what? Their shape and size. So, here I have written parallel plate capacitor means that what? Both plates should be parallel. So if I will write here parallel plate like this one, then basically this is the view of plate. I mean like that. When I will draw their front view, then it will be like a line. I mean when you will view the plate from my side, in that case it will like a line. So I will represent by these things. Now this is the plate and both plate are kept here parallelly. So it is known as parallel plate capacitor. Suppose on this plate, this is the positive charge, this is the negative charge. Basically this sigma is known as surface charge density. This sigma is known as surface charge density, and surface charge density, all of you know about this one. Surface charge density is equal to charge per unit area. Linear charge density is equal to charge per unit length, and volumetric charge density is equal to charge per unit volume. I have already discussed these things. So here I will use about the surface charge density. Suppose the distance between the two plates is d. This plate consists positive charge. So on entire plate, this is the positive charge. This is the negative charge. Negative charge. And their area I will assume A. Area of plate. So their strength will becomes, in that case their strength will becomes C is equal to epsilon naught A upon D. Now all of you know about all the terms. Epsilon, it is the permittivity of free space, and A is the area of plate, and D is the separation between the plate. So capacity of parallel plate capacitor epsilon naught A upon D. Now when you will insert dielectric between these two plates, then it will becomes C is equal to K epsilon naught A upon D. When you will induce the dielectric, different type of dielectric we can insert in between the capacitor. If I will use water, then it will becomes the water capacitor. If I will use air, then it will becomes the air capacitor. If I will use mica, then it will becomes a mica capacitor. So basically this is the also the classification of capacitor on the basis of dielectric. So different when I will use the different dielectric, then different type of capacitor will form from here only. So from this topic we want to discuss only two terms here. Again I will discuss about the parallel plate capacitor, their derivation I will discuss. But first everyone will keep in mind, because this is the fundamental terms and you have to keep in mind the strength of this parallel plate capacitor. Strength of this parallel plate capacitor will become epsilon naught A upon D. Basically in capacity I have already discussed it is used to create the constant electric field inside it, to maintain the vibration in the circuit, and to store the charge. So every term I will discuss here. Now I have already discussed type of capacitor on the basis of configuration of plate. So here also their strength depends upon what their configuration, I mean their plate area and the separation of plate. So these things you have to keep in mind. One by one I will discuss this all the things. How I will, main question is sir, how it will derive. So I will derive this equation separately. If you will say, then now only I will discuss. So one by one I will discuss about these things. If you will say derive these things here only, then no problem. This is the basic thing. How I will derive this formula? So everyone will concentrate here. From the basic term, first term I have used, it is used to create the constant electric field inside it. So first we will check the electric field about at all the point. Suppose 3 points I have considered in parallel plate capacitor. One is inside, and 2 point is outside. So if we will calculate the electric field inside it, then there are two plates. First upper plate and second one is lower plate. So for upper plate, electric field, direction of electric field should be downward like that, E. And for lower plate, it is the negative charge. So due to which also electric field should be what? Downward, E. And from a single plate, the electric field will becomes what? Sigma upon 2 epsilon naught. Here electric field due to this one is also sigma upon 2 epsilon naught. These things I have already discussed in electric field. So the net electric field at this point, suppose this point is P, so I will write here EP. So net electric field at this point will becomes what? Sigma upon epsilon naught. Now we will check the electric field outside the plate, outside of capacitor. So outside of capacitor, electric field due to this plate will becomes what? Upward, and their value I will assume E. And electric field due to this plate, it will become say downward, and it will be E. And equal in magnitude. How equal in magnitude? So here I will see E is equal to sigma upon 2 epsilon naught. It means that what? It is independent from the distance. So either plate is here or plate is here, no problem. If charge is same, then electric field will be same. It means that electric field due to this part will becomes what? Sigma upon 2 epsilon naught, and for this part sigma upon 2 epsilon naught, and direction of both electric field is opposite. That's why their magnitude will becomes what? 0. So outside electric field will be 0. Similarly, we can check electric field in downward. Electric field here E equal and opposite, it will be 0. So basically only inside the plate it will create the electric field. Now if we will calculate capacity, then from the simple definition we can analyze C is equal to Q upon V. We can write simply. So C is equal to Q upon V means that what? E into D. Electric field into separation between the plate we can take, and these things I have already discussed. Like V is equal to minus of integration of E into dx. I have already discussed these things. So directly I will write here V is equal to E into D. And electric field inside the capacitor will becomes what? Sigma upon what? Epsilon naught into D. So C will becomes what? Q upon Q epsilon naught sigma into D. And sigma is equal to, I have already discussed, charge upon area. So it will become C is equal to Q epsilon naught Q upon what? A into D. So it will become epsilon naught A upon D. Basically this is the derivation. So if I will write the type of capacitor, then at that time only I will write their capacity, which will depends upon the configuration. I mean shape or size only I will write. Every capacity, every type of capacitor has different capacity, and they are different value, and this value we can derive like that we can derive, but initially I will write only their capacity. So everyone will keep in mind only one thing. First, in parallel plate capacitor, capacity will becomes what? Epsilon naught A upon D. When I will introduce dielectric, in that case capacity will becomes what? K epsilon naught A upon D, where K is dielectric constant. Dielectric constant like a permittivity, relative permittivity. So Second type of capacitor is a spherical plate capacitor. Second type of capacitor is a spherical plate capacitor. Then I will discuss cylindrical plate capacitor, and then I will discuss Z-shaped capacitor. So B1, this is the spherical capacitor. So only I will write the result here because their derivation is based on the simple mathematical concept. So this is the first plate and this is the second plate. Suppose their radius is A. Configuration means that what? Shape and size. So suppose this is the first plate and this is the second plate. So their shape is spherical in nature and their size means that what? Their radius is A. And now the radius of second plate I will assume B. Suppose this is the positive charge, this is the negative charge. Then now it will becomes the spherical plate capacitor. So their strength will becomes, it means that what? Their capacity will becomes 4 pi epsilon naught upon 1 upon B minus 1 upon A. These things I will keep in mind. I mean their simple form I can write 4 pi epsilon naught AB upon B minus A. Simple form. So basically this is the capacity of a spherical plate capacitor. This is the capacity of a spherical plate capacitor. Here their capacity only depends upon what? Permittivity of free space and radius of two sphere. Here radius of two sphere is what? A and B. So their capacity will becomes what? 1 upon B minus 1 upon A. Their derivation is also easy. Simply we can derive, but not their derivation I will discuss in the next topic. Next topic I will discuss because when I will discuss their derivation at that time, we will take a different situation. Here I will discuss only the type of capacitor. So two type of capacitor I have seen here now. First one is parallel plate capacitor and second one is spherical plate capacitor. Similarly, third one is cylindrical plate capacitor. So in cylindrical plate capacitor, similar, this is the first cylinder, this is the second cylinder, this is the second cylinder, like that. This is the second cylinder. Their length I will assume L, and suppose positive charge on the first plate and negative charge on the second plate. Their radius I will assume A and their radius I will assume B. So their capacity will becomes what? C is equal to 2 pi epsilon naught L upon ln B upon A. What is this? Basically, this is the capacity of this cylindrical plate capacitor. L is the length of cylinder. A and B is their radii. Ln means that what? Neperian logarithm. I mean natural logarithm. When we will convert natural log into 10 base log, in that case we will use this concept 2.303 log something x. If it is log x, then here we will multiply by 2.303 and then it will convert it into what? 10 base logarithm. This is the natural log or Neperian log. When I will multiply with 2.303, then it will convert it into what? 10 base log. Like if ln2 is written here, it means that what? 2.303 multiplied by log 2. Like that, their value I will calculate. So this is the cylindrical plate capacitor. Their derivation is also like a parallel plate capacitor. First I will calculate the potential difference between the plate, and then I will use the formula C is equal to Q upon V, and then we will calculate the capacity. And finally I will got 4 pi epsilon naught 1 upon B minus 1 upon A. This is the capacity of a spherical plate capacitor, and this is the capacity of cylindrical plate capacitor. Their derivation is also similar to like that. And I will derive their capacity. Now third type of capacitor is a Z-shaped capacitor. Third type of capacitor is, fourth type of capacitor is Z-shaped capacitor. Z-shaped capacitor. So basically this is the first plate, parallel plate. This is the second plate, and this is the third plate. This is the first plate, second place, and similar plate I will keep like that. Suppose this is the dielectric constant between these two plates, and this is the dielectric constant between these two plates, and both plates kept at a distance d. And suppose their plate area is A. Plate area is A. Like that. Or simply we can say A square. If it is a square plate, for a square plate, so this is also a type of capacitor, and their capacity will becomes C is equal to epsilon naught A upon D into K1 K2 upon K1 minus K2 ln K1 upon K2. Their derivation is too long, and this will be derived with the help of concept of differentiation and integration. How I will use? So elementary part I will consider, and both part form the two capacitor and both are in series. That's why their capacity, suppose their capacity DC, a small capacity, for this part it will becomes a small capacity. So their derivation is long, but their result will become epsilon naught A upon D into K1 K2 upon K1 minus K2 ln. Ln means that what? Natural log K1 upon K2. This is the simple formula, and the derivation is not simple because it will take time and a lot of concept related to this formula while we will derive this formula. So what is the application of this concept? Suppose here in one plate I will use air. Suppose here I will use air. In first plate I will use air. K1 is equal to 1. This is the K2 is equal to K. Here some dielectric, here is air. In that case their capacity will becomes water. C is equal to epsilon naught A upon D. K1 K2 means that what? 1 into K upon 1 minus K ln. K1 upon K2, I mean 1 upon K only we have to write. So it will becomes epsilon naught A upon D. K upon 1 minus K ln 1 upon K. So basically their application is too important. Their derivation they can ask application based derivation. They can ask in advanced examination In mains examination, directly they will ask on the same concept. Directly from here they will ask. So this is the type of capacitor, first thing. Second thing, I have already told you initially when I will insert the dielectric inside the plate, then their capacity will change. So one more concept I want to take from there only. What will be the concept? Concept is capacitor with dielectric. Capacitor with the dielectric. So there are two situations created from here. First situation is when I will use for parallel plate capacitor. For parallel plate capacitor, when I will use complete dielectric here. This is the separation between the plate. This is the surface charge density, positive, negative, and this is the dielectric. I mean, complete dielectric I have placed. And second scene is the small thickness of dielectric I will insert between them. There are two situations. Both have the different capacity. In first case, directly we will write C is equal to K epsilon naught A upon D. Directly. But in this case, if T thickness of dielectric, their strength is K, dielectric constant is K, and their thickness is D. In that case, it will form the two capacitors, and both are in parallel. First capacitor is air capacitor, and second one is dielectric. With the dielectric, this will form the one capacitor. So for air, it will become epsilon naught A upon D minus T. And for dielectric, it will become what? K epsilon naught A upon T only for this part. And both are in series, so their equivalent will become what? C air multiplied by C dielectric upon C air plus C dielectric. And when I will put these all the result, then their expression will become what? C equivalent is equal to epsilon naught A upon D minus T plus T upon K. This will be the result. Now this is all about the type of capacitor. This is all about the type of capacitor. The next concept I will discuss in the next class. Thank you everyone.